Hi, hello everyone. Today we are going to see about Laplace equation in cylindrical coordinates. So consider the Laplace operator of three dimension in the cylinder coordinates. So it is in the form of three dimension, that is rho and pi and z. So the form of del 3 Laplace of third derivative three dimension will be dou square by dou rho square plus 1 by rho dou by dou rho plus 1 by rho square dou square divided by dou pi square plus dou square divided by dou z square. So our function for this form, we consider the function of u of rho comma z e power I r pi. So take here del 3 of u of rho comma z e power I r pi can be written as in all the del 3 into u, so it will becomes u of rho comma z e power I r pi into all the terms. So dou square u divided by dou rho square of this term plus 1 by rho into dou u by dou rho of e power I r pi. This is nothing but del 3 value into u form. Okay. Here what will happen to this form is 1 by rho square, as it is we have to dou square divided by dou pi square. Here our u of what is our e power I r pi. So with respect to pi, if we differentiate it two times, means what we get I r e power I r pi, and one more time means I square r square e power I r pi. So I square is minus r square e power I r pi. So minus r square e power I r pi plus this term as it is dou square u by dou z square e into I r pi. So taking e I r pi as common means we get this form. This first three term will be in the form of biharmonic form of what value we are consider, that value we have to put here. B nu, here it is not, or B nu of f. So what is our, here our values u. So B u or B nu u plus this form is nothing but consider d as dou z by dou z, means dou square means nothing but d square of u e power I r pi. So taking the Hankel transformation for both sides, we could have h nu of del 3 of u of rho comma z e power I r pi, rho tends to epsilon, that is equal to h nu of b nu plus d square u of e power I r pi, rho tends to xi. So this is taking Hankel transform on both sides. By using eighth equation, we know that h nu of b nu of f comma xi can be written as minus epsilon square h nu of f of rho comma rho semicolon xi. So for that we replace b nu as nothing but this can be replaced as minus xi square h nu of f of rho comma xi. So instead of this we have this term. So uh, we could replace this as minus psi square h nu of our form is nothing but u of rho z e power I r pi. So u of rho comma z, and here having additional d square value, so we take this d square minus epsilon square h nu of u of rho comma z, rho tends to epsilon, and e power I r pi as common. So then what we do means taking this as u bar of epsilon comma z. So this is equal to u bar of epsilon comma z e power I r pi. So our h nu value is nothing but d square minus epsilon square xi square u nu or u whatever u nu bar of xi comma z rho e of I r pi. This is our value. Hope you all understand, and thank you.